So, if you're an engineering student, you've probably heard the word methodology thrown around. And let's be honest, it can sound a little academic, a little dry. But what if I told you it's actually the most important, most practical tool in your entire toolkit? Let's dive in and see why. All right, first things first, we need to bust a myth. Because when people hear methodology, their minds usually jump to one very specific place. You're probably picturing this, right? White lab coats, beakers, super controlled variables, a classic scientific experiment. And look, that's definitely a kind of research, for sure. But that's just not what most engineering projects look like day to day. Engineering usually isn't about just observing something in a sterile, perfect little bubble. It's about getting your hands dirty. It's about building and fixing and optimizing things out in the messy real world. At the end of the day, every single engineering project, big or small, boils down to one thing: solving a problem. And you can't just wing it when you're solving a big problem. You need a plan. So, let's think about methodology in a new way. Forget the rigid rules. Think of it as your project's master plan. It's your blueprint for getting from point A to a successful solution. Okay, here's the official definition. A methodology is an operational, step-by-step plan, and it has two really critical jobs. One, it guides you towards solving the problem, and two, it helps you generate real, verifiable evidence that your solution actually works. It's not just enough to say you fixed it, you have to prove you fixed it. So what goes into this blueprint of yours? Well, it's pretty straightforward. You've got phases, these are the big picture stages. Then you have activities, which are the specific to-do items within each phase. You need your tools, and that could be anything from a piece of software to a specific analytical technique. And finally, the big one, validation. This is how you're going to prove it. How will you show, without a doubt, that your solution is the real deal? Now, I know this can all still feel a bit theoretical, so the best way to understand this is to see it in action. Let's look at how this blueprint idea plays out across a few totally different kinds of engineering projects. Let's start with a classic, failure analysis. You know, when something breaks and your job is to be the detective and figure out exactly why. Here's the blueprint. The tool? Something awesome like X-ray tomography. It's basically a CT scan for a machine part, letting you see all the internal damage without ever cutting it open. The activity is using that tool to create these super detailed 3D scans of the wear and tear. But here's the key, the validation. It's not just looking at the picture. It's building a computational model that shows exactly how and why that debris was generated. That model is your proof. Okay, next up, process optimization. How do we make things run better, faster, or smarter? This could be anything from a factory assembly line to the workflow in a software company. For this kind of project, the blueprint looks totally different. The activity might be something as simple as observing workers and timing every single motion they make. The tool here isn't a machine. It's a set of ideas, the principles of motion economy. And the validation? It's a clear, simple metric. Did we improve efficiency by 10%, 20%? The numbers don't lie. It's amazing how flexible this framework is, right? All right, let's look at one more, and this one's a bit more complex. Design optimization. Imagine you're tasked with designing a brand new component for an airplane. This is where your methodology can get really powerful. The activity is laying out all the rules, the constraints, the goals. The tool? A cutting-edge machine learning algorithm that can explore thousands of possible designs way faster than a human ever could. And the validation? It's finding a near-perfect solution that checks every single box. So we've seen a model, a metric, and now an optimized solution. 3 totally different ways to prove your work, all built on that same blueprint structure. So we've gone through the what and the how of engineering methodology, but we have to finish with the most important part: why. Why does having a good plan matter so much? It's about way more than just getting the project done and getting a good grade. This quote really hits it home. As engineers, you're held to a formal code of ethics. The work you do has real consequences, and the whole point, the ultimate outcome, is to make things better for people. And that's the bottom line. A strong, well-thought-out methodology is your guarantee. It's what ensures your process is solid, your results can be trusted, and that your final solution is ethical, safe, and actually helps people. It's how you put your professional responsibility into practice. So, as you get ready to tackle your first big project or your next one, don't just dream about the final result. Take a step back and think about the plan. Ask yourself, what's my blueprint going to look like?